Morning everyone, welcome to this Graitec webinar where today we're going to be looking at the workflows between Revit and Advance Steel with me, Rob Merriman. Okay, so a little bit about me. My contact information is there on the left hand side. This presentation has been created as a PDF handout, so if you do have any questions, you've got my contact information there. I now am up to about 12 years of experience in the construction industry. It is the only industry I've worked in since I left university. I started off as an architectural metalwork and structural steelwork draftsman, and I've been using Advanced Steel my whole career. I worked in 2 subcontract drawing offices, so over those first 8 years, that's allowed me to work with lots of different fabricators on lots of different projects. And I'm now working as an application engineer for Graitec UK, working on demonstrations, training, technical support, implementation, customization for structural CAD packages. And these days basically just cover everything to do with structures within the AEC collection. A little bit about Graitec. So we are 30 years old, headquartered in France, and we operate over 11 countries through 48 offices. We are becoming one of the largest Autodesk partners worldwide. We've got 550 staff, 100 of which are based in our research and development center out in Romania, so creating our own IP and solutions such as advanced design, and advanced workshop, and obviously the power packs. And we are here to work with you guys and help you guys. So why Graitec? We've broken the product lifecycle down into 4 areas. So they are Graitec Create, so using the Autodesk products and then enhancing them with the Graitec Power Packs. Simulate, taking your model and actually making sure it will work for the real world, so with technologies like advanced design. Fabricate, Advanced Steel sits in Fabricate, because obviously we are creating that fabrication data, but we do have tools to manage your workshop and your deliverables on site, such as Armor Plus and Advanced Workshop. And then all of those areas produce work in progress and BIM data, and usually you've got to collaborate with multiple external common data environments. So we have Graitec OpenTree that will look after all of that for you. Our Graitec content portals and content centers, you can see the link there. All the webinars are recorded and added to the content center. So it's industry workflows, best practices, tips and tricks. And we have a dedicated content portal for the AEC, MFG and structures industry. Generally takes up to 2 weeks. So this webinar will be added to the Advanced Steel and probably the AEC content portal, because it's Advanced Steel and Revit, within the next 2 weeks. Just because we're going to look at Advanced Steel to begin with, a little bit about the Advanced Steel Power Pack. So it's Graitec's add-on to Advanced Steel. This is a true statement in the UK at least. I can't speak for other countries, but if you're a supported and maintained customer, it's part of your package. And we break that down into 5 key areas. We've got the Structure Designer. It allows you to model complex structures within one dialog box. So everything you see on that picture there was created with the one dialog box. We then have our own connection vault. So we've got 25 extra connections in there. We then have our own create macros. So we can do castellated or cellular beams. We've got folded plate extenders. Some tools for creating helical or spiral polylines and beams. We've got some BIM import and export tools, so exporting the model or parts to ASYS, DWG, STEP and IGES, a 3D PDF. If you're doing Kingspan mezzanine floor beams, there's now an export tool within there. And we do also add extra data to your Advanced Steel via the Power Pack. So we've added extra cold rolled suppliers, extra sections such as FH Brundle weld mesh and the ISO standard screws in there. So on to today's webinar. We're going to start with some transferring words of wisdom. Then we're going to look at the Advanced Steel extension for Revit, what will transfer, what the extension settings look like, and then we'll look at some demonstrations. The demonstrations I did pre-record on Wednesday and it didn't all go to plan. and I have actually had to send the models off to Autodesk because we found a bug in there. So what went wrong, and we'll have a look at what's been done with it at the moment. So the transferring words of wisdom. I was in a meeting with a colleague, and he explained to a client about the transferring. It wasn't actually between Revit and Advanced Steel, it was for something else, but I think it holds true for anything. Whenever you're transferring any project between different programs, it's never going to be perfect. These programs are written by different companies in different programming language with different end goals. So, for example, although Revit and Advanced Steel are both in the AEC collection and they are both owned and are now developed by Autodesk, they were programs that were acquired by Autodesk. So they were written in different languages by different companies with a different end goal. So the transfer will never work perfectly because you're trying to take something from the Revit model and shoehorn it into Advanced Steel, or the Advanced Steel model and shoehorn it into Revit. If we take a car as an example, if you took a gearbox from like an Audi A4 and tried to fit it into a Ford Focus in the UK, it would not work perfectly without any modifications. It's still a gearbox, but it has a different mounts, different brackets, different electronic control system. There's no different when we're trying to take these models between two different programs. So when we're creating these transfer files, certain elements or functions may not transfer because the program we're trying to transfer it into can't deal with that particular function or that particular option. So today we're going to look at Revit and Advanced Steel transfer. So in your Advanced Steel, the import, export, synchronize options are already installed. You don't need to do anything. For Revit, before 2019, the extension you need to download from your Revit App Store. Just search for Steel and you'll see the downloads. Make sure you install a correct version. And as with anything when we're installing it, make sure that you actually close your Revit before installing or doing any updates. Once you have, I think I must have missed something there. After 2019, it's available in your desktop app, or it's available through your Autodesk account. So if you go to manage.autodesk.com, you'll see it in there. Once you've installed it in Revit, it's under add-ins under the Advanced Steel extension. Now, all of this is being shown in the PDF handout that's part of this webinar. So I'm not going to go through everything, every line step by step, but you can see from 2016, 2020, that should say 20/2021, most things do transfer. You can see in 2016 grids didn't transfer because, again, these transfer mechanisms take the Advanced Steel grids and then convert them into Revit grids. So for the programmers, that is a fairly big challenge. For plates before 2019, you couldn't draw plates in Revit that weren't just generic families. You now have the Steel tab in 2019, so you can create plates in Revit and transfer them to Advanced Steel as Advanced Steel plates. You can't in Revit create folded plates, twisted folded plates, or conical folded plates. So you can't go from Revit to Advanced Steel with those items because you can't create them in Revit. The big change you will notice, are for the connection elements and the beam features. So from 2019 onwards, with the addition of the Revit Steel tab, you now have the option to create bolts, anchors, welds, holes, shear studs, and beam shortenings, cuts, copes. So you can create them in Revit, and they will now transfer because the tools exist inside Revit to do that kind of stuff. Now, within the extension inside of Revit, you have some extension settings. In Advanced Steel, it will just do everything. So again, different versions, we've got different options. So in 17, you could import the plates. You can import only structural elements or export only structural elements. You can choose to import grids. 2018, if you had custom profiles, you could make those dynamic. That doesn't exist anymore. Now, when you compare 17 and 18 against 19, it looks like a lot of the options have disappeared. Well, actually, they've just been merged into the background. So your import plates, you no longer have the option to say, I want to import plates or don't want to import plates. It will just import them for you. So it looks like options have been removed, but they've just been integrated into the extension. So what do some of these mean? So disable joins for beams. In Advanced Steel, we can model two rafters like this, and they won't automatically join because Advanced Steel doesn't automatically join sections. But Revit automatically joins them. So you can disable that so they come through as they would in Advanced Steel. If you're starting your model inside of Revit, when you draw some beams coming into a column, Revit will automatically shorten the beams to the web or the flange of the column with a 10mm gap. Now, you have the option to include that export when you send it to Advanced Steel, but we don't want those extra shortenings because we're going to put connections on inside Advanced Steel. Export custom profiles as dynamic. If you've got custom families in Revit that don't exist inside of Advanced Steel, they are generated as user sections. Export based on view settings will only export what's shown in the Revit view. So you can set up custom views so that it only shows the steelwork to export the steelwork. So that is the basics. We're now going to go through about, I think it's about a half hour. Like I said, I pre-recorded it on Wednesday, just in case we did have any hiccups, and we did, that we had to send to Autodesk. And then we'll explain that at the end, and I'll take some questions at the end. But today's demonstration, although we're going to start with the simple shed model, we are going to go up through the complexities of model and do a couple of weird and different things so that you're not just seeing the same old structural models being transferred. You can see what will, what won't transfer with some more architectural and some different types of model. Okay, so we are going to start with our basic Advanced Steel training model. For those of you who've done the training with us, you will recognize this. The model is finished and I have numbered it. So we're going to go to the Export and Import tab, go to Export. We'll create the SMLX file. That will create the SMLX file in the bottom left of the screen. Sorry, bottom right of the screen even. And that's my SMLX file created. So I'm going to come to Revit. We'll look at this model in a minute, and we'll start a new template file. Now, for everything I'm doing today, just to speed things up, I'm going to start a new project. I have a Graitec Steelwork template file. Now, what we've done with that template file is I've basically loaded in all the UK steel sections. Because what you'll find is that when we go to the add-ins tab and we do the import, we'll go to our desktop. There's our SMLX file. If I didn't have every section loaded in, I would then have to start mapping it. Now in here, it is wanting to map a beam, and it's an R 0.3 by 0.4. So if I go back to the Advanced Steel model, that is actually our concrete beams. 30 centimeters by 40 centimeters in Revit, 0.3 meters by 0.4 meters. So I don't actually need to map that. We can just click OK, and that will generate automatically the Revit concrete beam. So you can see it build in the model. At the moment, I can't do anything. I've got to let it create all the sections and actually build a model. So if we get that, this is Revit telling me that if these beams didn't have connections, they would have the start end cutbacks. Now, because a connection has been applied to those, the start end cutbacks won't be taken into consideration. So you see that all these are cyan at the moment. This is telling me there's a background process going on, and you can see in here we have the background processes. So it's applying the connections and making the changes to the steelwork. So while I let it finish doing that, you'll also see the holes I've manually put in this beam. They've come through, and I do have some colour set up in here. Now, the one thing you will notice is in here, the silo, that hasn't come through. So that is our silo there. Now, that is an Advanced Steel special part. Now, the current workflows with the SMLX file, special parts, they are included in the SMLX file. If I brought this SMLX file back into Advanced Steel, it would create the special part, but there's no functionality in Revit to create a generic family from an Advanced Steel special part. So we will have to do that one separately. We need to copy it into a separate file, explode the Advanced Steel intelligence and copy it from 000 to 000. And then we can link it in. Now, what I'm going to do is I'm going to use the power pack function to that. I'm going to use the model to solids, and you'll see that I have the silo selected. So because I've got the silo selected, when I use model to solids, it will create the file for me. So we'll put it in, we'll call this ASYS export. And we'll call it shed. We'll do a DWG 2018 format. That's fine. That will use the Power Pack export, and that will create me that file. And then what we can do is we can either link the CAD or import the CAD. So if we import the CAD, it will become part of the model. If we link it, it is linking the actual DWG file. We can update it. So if we look in here, we'll bring that in, and then that is the way to bring in special parts. So that's Advanced Steel to Revit for a simple steel model. We'll put that down. We'll now go the other way. So this is a model created by our structural engineer or the engineer for the project. This has been purely done inside of Revit using the steel tab that is available in Revit and the connections that are available in Revit. So this is going from the engineer side down to the Advanced Steel draftsman to do the detailing. So what we'll do is we'll do add-ins, export. We'll put it in that same folder. That will then go and create the SMLX file. We'll start a new Graitec template file. And we'll go to the export and import tab, and this time we'll import from Revit. So we're going to be doing a lot of this in this webinar, but we're going to be doing it. We'll start with the simple models and then we'll move up through the complexity. Now, what we have in here is it's wanting to convert materials, because in Revit, out of the box, if I look at the materials for these plates, these are usually a metal deck, but I've changed them to the Revit materials Steel 43275. Now, that material doesn't exist in Advanced Steel, so we have to do the mapping. So I'm going to choose my S275JR. Now, you don't want to ignore or just click OK on random materials in here, because this gets logged in a database. So even if I get a different model, whatever I choose now gets logged, and it will do it automatically the next time round. So again, it's doing the same thing, but this time it's building it in Advanced Steel. So we must have a couple of different, one's for plates, one's for beams. So we now need to look at concrete. So I'll map it to a couple of the concrete sections. We'll map these to C20. Ideally, you want the same materials in both models. But that is that Revit steel model imported into Advanced Steel, and the connections that we have in here, they are connections inside of Revit, and if I go join properties, they are connections inside Advanced Steel. So we could update that and then synchronize it. So that's the first sort of basic workflows for structural projects. That is the most complicated one. So we're going to go to staircases. So this is the model that Alec created with the Secrets to Stairs and Secrets to Railings webinars that he's been running, which will be available on our content portal. So again, I've done my checks in here. I've numbered the model. So we will go straight to exporting. And we'll come back to Revit and close that file down there. And again, this one is something we're going to look at in a little bit. So again, we'll start a new Graitec steelwork template. We'll go to the add-ins tab and import. Now, there's obviously a lot more in this one. We've got stairs, we've got railings, and I do have some mapping that I need to do. So although I have certain things in there, if the information doesn't quite tally up, it won't map it properly, or possibly even in Revit, the 40x5 doesn't exist within the family. And what we need to do is we just then need to start mapping it. So you see in here straight away, I have some 8s, but it's the other way around. So in Advanced Steel, it's FL 40x8, and the families that I've got in Revit is 8x40. So we will have to fill in this dialog again. Once we've done this, it gets logged into databases. Now, if you're doing custom sections and you get to this point and you don't have a section to load, you would then have to go and create the family inside of Revit to actually do the mapping. So I do have all of them for this one. Now, this might take a little bit longer than the basic structure because there's obviously a lot more members to create. But we're not gonna do any smoke and mirrors or anything. I am just gonna give it its opportunity and let it build a model. You can see though it put in the mezzanine in, the railings in. We might get a few warnings depending on what it wants to do with the railings. What you have to remember with stairs and railings especially is they are completely different tools in each package. The Advanced Steel stairs and railings will create everything as structural members. So as we talked about at the beginning of the session, the Advanced Steel extension, the import-export, works with structural columns and structural framing. Everything that we create in Advanced Steel is a structural beam or structural column with bolts and welds and notches in. The Revit stairs and railings tools are family-based, that is Revit technology. So when we import, it is not going to convert the Advanced Steel staircases into a Revit family staircase, and vice versa. When we take the Revit family stairs and railings tools, it is not going to convert them into Advance Steel objects. Although they're both stairs and railings tools, they are completely different bits of code. One's family based and the ones in Advanced Steel are based on the individual beams and items. So again, we've got a couple of warnings in here. The start end cutback is because, like I said, we have connections in here. It do have a couple of warnings, and it is still building some things in the background. So we will let it finish what it needs to do. Okay, so that's finished. So something hasn't quite worked out properly. Let's see what this is. So it's a concrete beam in there. Oh, I must have mapped this incorrectly, or I must have modelled this incorrectly. Let's have a look. Let's go back to our Advanced Steel. See why it wants to do this. I think I've modelled it as a different section. See, on here we have a PFC, and in here we have a channel UPN section, so I must have forgot to change that, and the mapping dialog is wanting to change that to an Advanced Steel concrete beam. So we can, and this is where you sort of need, ideally you want to have control over both elements. We should be able to change this in here to our PFC section. Okay, so we do have, like I said, a problem with that it thinks it's a concrete beam. And we are missing a couple of the folded plates. Weirdly, it's brought in some, but not all. So you can, because these are just Advanced Steel elements inside of Revit, we can select the individual items and delete them. And what we'll do, we'll go back and correct the Advanced Steel model. I will send this recording to Autodesk and these models and get them to investigate. See, every time I go, when I'm deleting certain things or I'm deleting connections and welds, it is updating. So what we'll do, we'll come back into our Advanced Steel model and we'll just go into the joint properties for we'll go to the step bottom, the landing bottom profile, and we'll change this to the UK parallel flange channels 200 by 75. So that's what it needs to be. And then what we'll do is we'll do a clear marking and display objects connected in shop. So we'll just select all of that. We'll select it, double check that the number stayed on for this one, which it has done. So we'll select it again, and this time we'll just do an export for just the staircase. So we'll call this just staircase 1. And then what we'll do, we'll come back to the add-ins and we'll import. And my machine decides to catch up with me. So we'll just bring that staircase in. You'll notice I didn't have the mapping dialog this time. That's because what I set earlier on has been remembered. It has been stored in a database. So even if I shut my Revit down, started a new file, created a new file in Advance Steel, if it uses those sections that I've created in the mapping, it will be included automatically. I still don't fully understand why my treads haven't come in, so what I'm going to do, I'm going to carry on, because this was actually recorded a couple of days before this webinar, and I will do a bit of investigating. But like I said, I am doing these on models that we have created in Advance Steel and we have not tested, so these are the results that we are getting that you guys would get as the end users. So let's look at it from the other point of view. If you've been given a model that has been created inside of Revit, and then you need to do the detailing of the balustrade and say the metalwork and the steelwork on the project. So we have this very shoddily drawn building. This is my building, and what I'm going to do is I'm going to create a new view. I'm going to duplicate this view, and we're going to rename it as AS Export. And then what we can do in here is what do we want to see in our export? So I'm not interested in the windows. They wouldn't go anyway, but I'm going to hide the category. I don't want the curtain walling, so we can hide the curtain walling category. We'll do the elements. Do we want the doors? Probably not. So we can either just do it by category, or what we can do is come into the visibility graphics and we can then start to have a look in here, like, do we want ceilings? Well, not in here. I don't want ceilings. I know I've got ceilings in here. Light devices and lighting fixtures. So, and then you could save that information. Now what we do have in here is if I just temporarily hide that wall, you can see we've got a Revit staircase. So there's my Revit concrete stair. There's some Revit railings. For example, in there we've got some curved walls, we've got some, and I've got the ramps and the railings in here. So that, for me, as the Advanced Steel draftsman, that is what I'm bringing into Advanced Steel. But I might want, I've got some steelwork in the roof, so I might want the complete roof finishes. So I am just going to leave this view as it is for now. And then we're going to go Advanced Steel Extension, Export. Again, if I had stuff selected, it would export just what you have selected. We'll let that run the export. we'll go back to our Advanced Steel, start a new template file, and we will import, it was the office. Now we are going to probably have to do a decent amount of mapping in here because we've got concrete cast in situ. So although I said don't do it, just to speed up the import, I'm just going to map all my concrete to one layer. And then you see in here, because we've got different, Revit is a completely different program to Advanced Steel. So in Revit, you choose your wall, and then you can do the build up, and that will show in plan views and things like that. Advanced Steel, it just comes in with the finished thickness, and like the default roof, that's a material in Revit. Well, I don't have that in Advanced Steel, so I will just map it for now. But everything I'm clicking on at the moment is being logged in a database. So if you just randomly just click OK on everything, it will remember that the next time you import. So I don't have my window openings, but I do have my wall. If I turn that off, I do have my floors. I do have, it has attempted to bring in my internal curved walls. These openings are the openings in the wall. You can see I've got my structural steel. Now, interestingly, it has brought in the Revit stair. Now, what it has done is converted that into a special part. So that is just a 3D solid. But it does have the correct geometry points, and it gives us something to work with in Advanced Steel. So even if I have to model a staircase again, I don't have to draw everything and use all the setting out points from scratch. Same with the ramp. It's brought the ramp, so it doesn't bring the top rail through on the handrails, but again, I've got the basic geometry points. Alec has even done a webinar in the past on creating concrete stairs with railings in Advanced Steel, but the same with the roof. Anything that you've asked it to export that it can't do, certain items like the stairs, the ramps, the roof will come through as special parts. So at least that gives me the endpoints to work with. If we go like endpoint and endpoint, to then set my UCS, which would then allow me to start drawing beams. So I could start drawing my hip beams for my roof. So again, we can go endpoint to endpoint. And then that's in there. Now we can see it's clashing, but because it's a special part, if I run a clash check, it will tell me that it's clashing, and I can actually see where it's clashing, and that then would allow me to drop the beam down by that depth, so I know that I've no longer got a clash. So although it's not brought everything through intelligently, remember it is only supposed to work with structural framing and structural columns, it will still bring through objects via the export as special parts. Now we're going to try and go real crazy, and the play park I modeled last week, a lot of this is curved items, poly beams, special parts, so we already know the special parts aren't going to work, but we'll see what we get with this export. So again, we will create one new steelwork project. We'll go to the extension and we will import. And we'll see what it wants to do. So it is asking to map a couple of sections. Obviously it doesn't like the difference in the round bars. And then we've got circular hollow sections. So in Advanced Steel, I've modelled that as 33.7 by 3, but in Revit I've got 33.7 by 2.6, 3.2, 3.2 or 4. So the 3mm wall thickness doesn't exist in the Revit families. So I will map it to a different size, but if it doesn't exist, then in reality we should be adding that size to the family or creating a new family to get our mapping correct. So if that dialog comes up and you're not happy with choosing a different section size, take a note of everything and then we can do some Revit family editing before we actually do the import. And that would be the same going the other way. So for that one, I'm actually pretty happy with that. So if you were with me last week, doesn't quite like the cutter object that we've done on the poly beams. And the reason for that is probably Revit can't handle the fact that this is a poly beam. So it split it into the 3 individual components. So we're missing a couple of cutter objects in here. There's one connection in there it doesn't like, but these items in here have come through. But in Advanced Steel, they are one item. They are a poly beam. So if you missed this webinar, you can catch it on our Advanced Steel portal. These are poly beams, and you can't draw poly beams inside of Revit. So that's why it has split them up into the individual components. But on the whole, that's not too bad. Now, if we weren't happy with that, now that we've imported it and we can see what it's doing, we then might say, right, well, everything that is a poly beam, we will do via the exploding it to ACES and importing it as just a solid and doing it through the power pack with the special parts. The Advanced Steel grating, so in Advanced Steel, we have this grating, and it is an actual Advanced Steel grating. And again, in Revit, there is nothing in Revit called grating. They don't have functions to create gratings as we do in Advanced Steel. You always have to remember with these imports and exports, they are different programs. So what it has done is it has imported it as an Advanced Steel plate. But we still have the geometry, the shape is correct, the bolts are still bolting through, we've still got the gap in there that we created last week. The connection on the underside, the welds have come through. These T's are cutting against the tube. This is a tube base plate macro. So while it's not perfect and it is throwing a couple of errors in here, the non-linear bits, it doesn't think they're in line, so that could have been the way I've modelled it. Well, if we have a look at the warnings in here, the connection has failed. Now that was a custom connection, so that is probably why I'm getting those errors there. But we do have most of the geometry. If you look at that, and you look at that, it's not perfect. And I think, like I said in the introduction, and I just said a minute ago, these are different programs written by different coders with a different end goal. At the time they were written, although they're both owned by Autodesk, they are still 2 different tools to do 2 different things. So when you're converting between any package and you're trying to convert one to another, it's never going to be perfect and seamless. But I actually think that is not a bad effort.
And if we're still not happy with it, we could then do the bits that we're not happy with as solids and then link or import them.
Okay, so that is the end of the demonstration. So what went wrong with that staircase? I'll be honest, I don't know. It should include it in the export, and I have sent it to Autodesk, and it's been passed straight on to the development team who are looking at it. They can replicate the problem with my model, so they are looking at the code within the extension. So unfortunately, we're probably going to have to wait for a hotfix. There is an official article that has been created about it, so you can click the link in the handout, and if they come back to me directly, I will post it on my social media and maybe even do a blog about it. But like I said, if parts aren't importing as you expect them to, we can do them as 3D solids and then link them or just import them into the Revit file, so at least we have the correct geometry points. And that pretty much wraps up our webinar, so I'll keep the session running for a few more minutes if anyone does have any questions. We have myself and John Bennett. I think this is about the 13th webinar, 12th, 13th, 14th webinar we've done on the Revit and Advance Steel workflows. So on our content portal, on the Advanced Steel content portal, there are a lot more webinars on the Revit and Advanced Steel workflows. But if anyone does have any questions, please type them into the question box. So Petros has asked, just for curiosity, do you think Revit will eventually replace Advanced Steel? No, it won't, and we have heard that from the Advanced Steel product manager and the Autodesk senior strategy manager for structures. We did an Advanced Steel user day for our UK customers about a month ago, and we had those guys from Autodesk there, and the question got raised. They are two different products, again, with two different end goals in mind. The steel tools have been added to Revit to allow engineers to produce models and details with a higher level of detail, but those engineers do not produce fabrication drawings. And they don't model the complicated stairs and railings and things like that. They use the tools in Revit to do the basic intent, and then it gets passed on to the actual steel detailers and the steel fabricators. So that's why we have Revit and Advanced Steel in the AEC collection. We can transfer models between them because one product is not going to do everything. So Autodesk strategy at the moment is they're not going to merge them. Egis has also raised a valid point. There is if you are having issues when Revit crashes when you're importing or exporting from Revit, there is a problem with the Microsoft Access Database Engine. It's a 2010 issue. I will just see if I can find the link because I did send it to someone this morning, and I'll put it in the chat window for everyone. Let me just copy that link. If I put it in the chat window, so if you do find that your Revit crashes when you're trying to do the SML export, there is a solution for it. So yes, thank you for that, Egis. Petros, like I said, on our content portal, we have done 13 other webinars on the Revit and Advanced Steel workflows, and some of those do cover synchronizing. If you make changes in one model, create the SMLX file, the other model will update. Again, it depends what you're creating, how you're creating it, and that kind of information. So yes, in theory, everything will update and sync, but as you've seen today, it depends. Is it poly beams? Is it things like that? But if you're using structural beams and columns with connections, they will update. So thank you very much for watching and attending today's webinar. Like I said, follow us and myself on social media. Keep an eye on the content portal. This recording will go up within the next couple of weeks, and hopefully we'll see you on future webinars.